Having discussed solutions, we now move on to the topic of electrolytes, or the electrical conductivity of solutions, which is actually experimental evidence for what we've been saying about ion formation in solution. So in recent lessons, we've presented two important facts. One is that binary compounds between metals and nonmetals are ionic compounds. And the second one is that ionic compounds dissociate in aqueous solution to form cations and anions. So far you've just had to take these facts at face value and believe us on them. But what is the experimental evidence to support these facts? Well, the most important piece of evidence is that solutions of ionic compounds conduct electricity. Okay, so how does this help us? Well, we normally think of metal wires as being good conductors of electricity, and shown on the right is a diagram of a battery connected to a light bulb by wires. And the reason why they can conduct electricity, if you look at the blow-up of the cross-section of the wire, is that electrons, which are of course charged particles, can move freely through the wire. Okay, so they can be carried from the battery to the light bulb. So if charged particles can move freely through a solution, the solution should act as a liquid wire and therefore should be able to conduct electricity. So to be able to see if this is the case, let's take a closer look again at ions in solution. So in the figures on the screen, we have a picture of an ionic compound dissolving in water and also a picture of a molecular compound, namely methanol in this case, dissolved in water. So when an ionic compound dissolves, the cations and anions separate and each one becomes surrounded by water molecules. The ions are free to move around the solution, okay, so those pluses and minuses that are surrounded by the water molecules can go wherever they want, so the solution will conduct electricity. For the molecular compound, when that dissolves in water, no charges are being generated at all. So you don't see any pluses or minuses in this picture. So as a result, the solution will not conduct electricity. Okay, so a couple of definitions. Substances that cause water to conduct electricity when they are dissolved are called electrolytes. And if an aqueous solution of a substance does not conduct electricity, then that substance is called a non-electrolyte. So ionic compounds and acids, as we met on the last lesson, are electrolytes, whereas neutral molecular compounds are non-electrolytes. Okay, so how do we measure electrical conductivity? So I'm going to present to you three devices, and the first is a low-tech device. So what happens here is you have a light bulb, and in this case it's plugged into the wall, but it could also be connected to a battery. It just has to be connected to an electrical source. But in contrast to what we saw on the previous slide, instead of there being a solid wire connecting the source of electricity to the light bulb, in this case we have two electrodes. And those two electrodes normally are not connected to each other in any way. So simply plugging this device in will cause the light bulb not to light up. If you take these, the reason why we have these two electrodes is you can take them and stick them into a solution and see if that solution conducts electricity by whether or not the light bulb lights up. So if you take these two electrodes and stick them into pure water, the light bulb will not light up because pure deionized water actually has no ions in it and does not conduct electricity. Now, water coming out of a tap in your house may have ions in it. In fact, it will have ions in it, and that can conduct electricity, which is why you might have heard of people being electrocuted in their showers. So if we take a molecular compound such as sugar and try to dissolve that in the water, and again hook up this apparatus and stick the electrodes in there, it will still not conduct electricity and the light bulb will still not light up because the sugar is molecular and does not form ions. In contrast, if we dissolve salt in the water, now ions are present in solution, the solution conducts electricity, and the light bulb lights up. Okay, a medium tech device is what I'm going to call a conductivity probe, and this is actually what we're going to use when we examine conductivity in the lab. So it's simply a 9-volt battery hooked up to a device that still has 2 electrodes sticking off of it, and the device has various LED lights on it. So you can stick the electrodes into a solution. Here we're sticking them into a well plate, and depending on how many of those red LEDs light up, the solution is either a poor conductor of electricity or a non-conductor of electricity if only 1 or 0 lights light up, or it's a good conductor of electricity if lots of the lights light up. And then if it's somewhere in between, that means it's a moderate conductor of electricity, and we'll talk about that in a minute. The highest tech device is a digital conductivity probe, so that is a device that has a digital readout screen and then usually a single probe that you can stick into a solution. And devices like this give an actual number for the electrical conductivity, not just a light on or off or a certain number of LEDs being lit. Okay, and these are frequently used out in the field in analytical chemistry to be able to test whether solutions conduct electricity and as a result, what the concentration of ions is in those solutions. Okay, so the last thing I have to talk about is what is the relationship between the conductivity and the number of ions in a solution. Okay, so the extent to which a solution conducts electricity is related to the number of ions in solution. So in the diagram here, we have on the left side no ions in solution. So in this case, the light bulb does not light up. In the middle, we have the light bulb only being lighted up dimly. Whereas on the right side, the light bulb is being lit up much brighter. So in the middle, where the light bulb is only being lit dimly, there are relatively few ions in solution, whereas on the right side, where the light bulb is lighting up bright, there are more ions in solution. And there are 2 different reasons why a solution will contain fewer ions. So the most obvious reason is that dilute solutions will contain fewer ions than concentrated solutions. And in fact, you can use conductivity as a way to analyze the concentration of a solution. You're going to get a greater, assuming it's an ionic solution, you're going to get greater conductivity for a more concentrated solution. However, for some substances, only a small percentage of the substance will dissociate upon being dissolved in water. The substance dissolves in water, but it doesn't dissociate completely. So substances that have this particular property are called weak electrolytes. And the most common example of weak electrolytes are the weak acids, which we're actually going to meet in the next unit. So I'm not going to say anything more about them right now, except to tell you that they're out there and you should be aware of their existence. Okay, so if weak electrolytes do not dissociate completely, strong electrolytes do dissociate completely. But some solutions of strong electrolytes are still going to light that light bulb dimly, be weak conductors of electricity, because in those cases, the compound may not be very soluble. And if a compound is not very soluble in water, the concentration of ions in solution will be very low, no matter how much of the substance you attempt to put into your beaker. Okay, so you remember, if you have exceeded the solubility of a compound in water and continue to add more of that compound, the additional compound that you add will just sit as a solid on the bottom of the beaker. And the extra solid on the bottom of a saturated solution does not add to the solution's ability to conduct electricity. Okay, so we have looked at how we can measure conductivity in the lab and how those conductivity measurements give us information as to whether a compound is an ionic compound or a molecular compound, and if it is an ionic compound, whether you have few ions in solution or many ions in solution.